Welcome back to BCW, proudly brought to you by Haltech. This week we are back at Flux 3D. You may remember recently Miles came down and visited and we 3D scanned all sorts of goodness on the GX81. He has now designed our cluster surround for the UC10 and also some other goodies including a keypad mount. So we've come down to check out the printing action as well as explore Flux 3D and also check out some of the cars that Miles has put together over the years and look at all sorts of other cool stuff, learn about some printing, the different technologies in printing, different materials, different processes, and also what they actually do at Flux 3D. So all sorts of things going to happen today. Let's get into it. For anyone who may have not caught our earlier episodes, this is Miles. Miles is the brains behind Flux 3D. This was originally started in his garage. So it's pretty cool to see how far this has come in realistically quite a short space of time. And the products totally evolve over the years. But I guess in a nutshell, what is Flux 3D today?
So we manufacture a lot of automotive parts for mainly ADAS relocation systems for tub to tray conversions on a dual cab ute or single cab ute.
Yep.
So things like blind spot detection, cross traffic alerts, reverse sensors, park sensors, all the wiring, cameras, that kind of stuff. Yeah, we do looms as well to try and simplify installations and make sure the car is seeing the geometry that it wants to see before it was modified.
The biggest thing that I've noticed, especially even in my area, so many dual cab utes that have had tray conversions, a lot of the OEs, the componentry is in the stock rear step.
Correct.
So many of the tray, for some reason, D-Maxes and BT50s seem to be the most popular one that they don't relocate it.
Yeah.
And so many of them, the sensors are actually way under the tray. Yeah. And that can actually create issues with the systems, right? Like sometimes it can actually see the tray.
Yeah. So yes, there's like a departure angle of the sensor. So if the tray is in that departure angle, you're going to get like false activations and things like that. Some of these cars, those systems can talk to like the steering because they've got electric power steering. So if it sees something, it might try and actually pull you,
steer you away from it.
Steer you away
it's
from
actually just trying to drive away from its own tray.
Correct. Yeah.
That's handy.
So when it sees too many faults like that, the car will generally fault out before it does something like that. But obviously, when you do this, you want to try and, if you're not changing the software on these modules, you want to make sure that the car is seeing what it used to see.
Yeah, actually representing the true data that it was designed around.
So people put 7-foot trays on a dual cab, which is crazy long.
That's another argument anyway, right?
That's right. It's not like legalities are kind of stretched, but then the radars are so far under the car that they're actually not doing what they're meant to do anymore. So they've either got to be moved out, but moved within reason so that you're not affecting the car's ability to see what it needs to see.
Because a lot of these parameters are linked to traction control, stability control, all the safety aspects of the vehicle, which are now required for ADR compliance. Then you have this whole other can of worms that if you remove or modify those systems in a way where they don't act correctly, you're now actually removing features that are required for ADR compliance. So
a lot of the features still at this moment in time, I think, depending on the legislation at the time, I think they're still a desirable, not intentionally required, but there are like reverse cameras now like a full, like you have to have them.
Really?
Blind spots will be another thing that is basically going to be mandatory very soon. And so you have to make these things work properly. And if you just cowboy slam them on the back of the car, somebody get the angles wrong, get something wrong, the car's not going to know what it's doing or detecting. It doesn't know you've changed anything. So suddenly it's having a heart attack about what it's trying to see and how it's trying to predict this data that you've gone and done something it has no idea. So we use like a lot of technology like 3D scanning, and obviously we try and get a lot of OE data to see and recreate our product based on that data rather than just trying to be like just throwing it on the back of the tray.
You're just guessing as well at that point, right?
A lot of tray manufacturers, they try and move the tech around their tray, and unfortunately it's becoming harder and harder to do that. So trying to squeeze it in places to
almost need to collaborate with the tray manufacturers at the point of design rather than try and reinvent the wheel and get everyone's systems working.
Correct. And so that's kind of where we're sort of in the last 3 months is where things have been going, where tray manufacturers are coming to us and going, can you make this work with our tray?
You're integrating your systems with their systems at a design level rather than here's a 2024, 2025 Amarok and all of a sudden everything's in the wrong spot, and then the tray actually doesn't work with the systems.
Yeah, correct. Yeah. So we're trying to keep it, and obviously every car's different. There's not one universal fits all product sort of thing. Every one's a different.
And that's what you're about, right?
Yeah,
it's not about generic stuff that doesn't quite work, because we were discussing before, you are actually from the installation game originally. You've spent years and years in the field dealing with the universal stuff, and now know, or from your experience on the floor fitting stuff, right? It's now you're engineering everything to be a single-use manufacturer-specific kit, or even model-specific in some cases. Yeah,
so you get things like, I used to do like park sensors, car alarms, things like that. And for a lot of the times, some of that stuff was universal, but then you would get given, go put this fascia kit into a car to put a stereo in, and it was this awful, sort of like generic universal kit. And you would spend 3-4 hours making the thing look good, where rather than that, you just like, if someone just made a kit that went,
and this is the other thing too, some of the products may be on the higher end of the price point, but you're saving so many hours in not having to manufacture, modify, cut, drill, weld. They just work.
Yeah, you just bolt it on. We have instructions, everything like, just bolt the thing on and it's good to go.
Yeah, that's wicked.
As long as you stick within, certain parameters, it's good to go.
Yeah, and what's the other aspect of Flux?
So we do a fair amount of custom work. So we'll get random walk-ins, whether it's a car person.
Guilty.
Yep. We can talk about that later. So like we've had everything from like dentists walk in here wanting bits made for dentistry stuff, like jigs and things like that to hold, fake jaws, all that sort of stuff. We've had one of the things that come up recently was the Aviation Museum down the south. They came to us and said, can you make us a door handle for Boeing 707? It was actually the airplane that John Travolta donated to that museum, and they're like, can we have another door handle? Because the replacement cost from Boeing was $7,000 for a door handle, and so we're like, we can make that for much cheaper.
And the thing is, in that particular instance, because the plane no longer needs to be airworthy, it doesn't actually have to be a certified Boeing component.
It's purely a cosmetic item.
It's filling a hole, right?
Yeah, that's right. So again, scan it, redraw it, print it, make some futuristic adjustments to it. So because obviously, back when that plane was built, it was, let's just, bubblegum it together, where now we have got clips and
it was actually bent too, right?
It was.
The sample you got was bent.
Correct. Yeah. So it was always, so obviously from like disarming the door, it's always bent
pulled
over
one
time.
way over time.
And so when we scanned it, you could see the bend in it, and we're like, do you want the bend back in it, or do you want us to just recreate a square one? They're like, just make a square one. So it was just one of those interesting things. We're like, do you want it to be purely like period specific, do you want that? So everything. So we do like custom parts. We'll just have random walk-ins, someone saying, hey, can you make this for us? We'll 3D scan it, we'll print it through the various things we have, like various technologies. We can outsource as well, so we can send stuff for like metal printing and that sort of stuff. We don't have that in-house, but
that's wild.
So you can just make make anything essentially. Like, it doesn't matter what you bring us, we can do something with it.
Sick.
Yeah.
Well, we could stand here and talk forever, but there's all sorts of cool stuff going on out the back. So
we'll look.
This is an SLS printed part, and it's something you guys designed in-house.
Yeah.
And what is SLS? Because I can say that 100 times, but what does it actually mean, and what is the process?
So it's selective laser sintering. So long story short, it's a big vat of powder, and there's a galvo laser that lives on top of this printer, and it shoots down into the vat of powder, and it essentially melts one layer at a time of the powder, selective laser, and then it wipes a new layer over, pushes the stack down, and it does it again. And so it's still printing by layers, but instead of oozing plastic out of a tube, essentially,
not extruding anymore.
It's not extruding, so you get heaps of fidelity and heaps of like strong parts. And with like you can make really thin walls. You can make complex things where you can print something like a sphere in a box, where you can't do that.
It's not contacting anything.
Yeah, because it's not contacting anything.
Because the difference with SLS too is there's no support material. Correct. The powder is the support material.
The excess powder that's not sintered becomes the support material for the rest of the part.
And looking at this component, the detail is just absolutely next level compared to the extruded style printers.
Correct,
Like, you've got clips here that are only about 1 millimeter in thickness, because this is replicating a component in a factory vehicle on this regard. Like
Correct.
obviously there's differences here that this is now a switch panel, but this was probably like a clock or something that clipped into the dash before, right?
Yeah.
And so you can replicate all of these clips without having to modify the dash. It's fully reversible.
Correct, yeah. It's a clip-in part.
And the other thing is too, it's just so thin and light compared to an extruded style component. Like you don't have all these extra pieces, and you also can't see the layer lines compared to a print.
That's right. So
or a traditional print.
Yeah, it's made of nylon 12. This one particularly is made of like nylon 12. They call it tough, and so it's got a lot of nylon 12 is generally very brittle. Yeah. But this one's got a lot of flex to it. It's also very heat resistant. It's very it's superior to like FDM printing in pretty much every way. I'm sure someone will complain to me, say no, this FDM's better. But
the one thing I guess that it is worth mentioning is SLS is a lot dearer.
Correct.
So this is not prototyping level. This is kind of production level, right?
Correct,
So
like
you'll do a lot of your prototyping in FDM, and then do your proof of concept or whatever. Or you might go between 10 different engineering concepts before you actually get to the SLS component, because the material is a lot dearer, and the machine itself costs a lot. So there's no point running $20 components through SLS because from a business, your ROI is never actually going to stack up.
Correct, yeah. So especially too when you say to someone like you're trying to say make a part for them on the cheap, or to be as cost effective as possible, and if you've got to do 10 revisions of this, then this costs $65 a pop, or it costs $40, whatever the like amount is. Where if you can prototype it on FDM first, then it's going to cost mid-dollars versus this costing a ton of money, because there's post-processing on both methods, but the part like this is a fully sandblasted and done part, and you could slap that into the car and you wouldn't think anything about it, except for maybe the colour's a bit off, but like there's no layer lines, there's no post-processing, it's just like
there's no painting, sanding.
So
I guess the argument for and against SLS versus FDM, this costs more on the surface, but when you receive it, it's ready for either final fitting, final painting, or directly installing. Whereas
slap it in,
FDM, you're going to have all these layer lines, and there's at least a couple of hours in sanding, high fill, then painting the final colour. And then if you actually want like a gloss paint style finish,
it's got to be.
There's lots and lots of hand sanding and painting, and whereas this you could basically do quick prime, and one layer of high fill, and then paint it a body colour, and it's going to look like a plastic bumper in that reflective, nice layer.
So you basically high fill it to seal it up. SLS is slightly hydroscopic, so it will suck in a little bit of. So if you're trying to paint it, it will sort of soak in. So you put like one layer of high fill just to like essentially seal it,
just level it out,
and then paint it. Done.
Sick.
So that's it. So. But yeah, we've got some parts in here to extract, so...
Let's crack the oven, but before we do it, we're going to put some masks on, and we didn't put them on yet so you can actually hear what we say, but the powder in this is pretty hectic, so we are going to mask up and glove up to pull it all out, and there's actually another part here, which is the cleaner sieve, right?
Yeah, this is a sifting station, so you basically got a printer, you've got a sift, and in the other room we've got a media blaster. So we take a build chamber out of this machine, jam it in this one. We essentially push the powder towel, or the cake they call it, over this sifting mesh, and we can essentially pull the part out. This will then recycle the powder that's not been used.
That was going to be my next question. Is the material recoverable that's not printed?
Yeah. So
that's
there's depending on the material, you've got a refresh rate you have to put in, so you have to put X amount of new powder in for some old powder.
Okay.
But yeah, you can reuse most of your old powder, and you just keep flushing it through. So there is obviously, there's technical stuff you've got to deal with, but yeah, ideally you can recycle what you haven't used.
That's cool.
Let's
do it. That's heckers. Create the cake. Wow.
It's like watching paint dry, right?
The future is now.
And you can just start like...
It's unbelievable
that it's just a part in there.
This is the first time I've seen SLS unpacked.
Yeah.
I've seen you make stuff before, but I've never seen it actually come out. And it's like, it literally looks like you just dug that out of the ground.
Yeah. So yeah, you've literally got to like excavate it out. So the part's in there, and we sit there and we'll...
And my other question was going to be, do you print multiple things in SLS at the same time? But you've already answered that question.
Yeah, so ideally you want, there's like a pack density you want of this chamber.
Yeah.
So if I printed this chamber and it was just that part,
yeah,
and it was this long, we're going to end up with heaps of like unused powder.
Yeah.
Powder only has a certain amount of cycles it can go through. So
yeah,
ideally,
okay, so even though it's reusable, you can't run it through 100 times.
Yeah, that's right. So you try and keep the pack density up so as to be able to get the most out of it. Because after a while, the powder's going to fatigue of being heat cycled up and down so many times. So it has to be like packed properly. And so doing a small pack run is generally what we can do. Is if someone does come through and say, "I want a part made," if we can backload it to another part, where we can bring the cost down. But if you go, "I want it now," then we have to charge you the whole build chamber.
Yeah, because there is obviously an impact of blowing through this powder.
Correct. Yeah.
And I mean, I don't know if this is even an on-camera question or not, but what does the raw material cost? Like, is it like $200 a kilo?
Yeah. So say for instance, FDM stuff is about anywhere between, so this is Australian dollars, $18 to $25 roughly for a spool.
Yeah.
This stuff is $200 a kilo for the...
And for 1 kilo of this nylon 12, what does that actually produce? Like in component forms, is that like 20 of these print chambers? Is it one of these print chambers? Like,
so you probably end up with, like, say, you buy it in a box of 10 kilos, and so that you need, obviously, you can't just say, oh, well, so an FDM, if I want to print a 20 gram part, it's going to be 20 grams.
Of course.
This might be 150 grams,
yeah,
because I've got to fill the rest of that chamber up. So it's kind of how long's a piece of string, but also, like, you know, you'll probably end up finding there's about a 20 to 30% loss over that powder.
Yeah.
So when we actually have to do this, we're going to have to sandblast some of the good powder off. We're not going to.
So you don't just literally tap it and it's clean, and you're only refining the part.
No.
There is actually like a margin of material that actually stays on the part that gets blasted off.
Yeah. So we are going to lose about 20 to 30% of that 10 kilos that we buy.
Yeah.
2 kilos gone, sort of straight away. So,
yeah. Wow.
So we try and clean them here as much as we can, so that we can salvage as much as possible before we essentially send it to the blaster. Because once it goes into the blaster, there's no way to recover it. Yeah, even the blaster's got like a sieving section in it. It will not.
You can't clean it down enough that you're not getting blast media in the nylon 12.
And then the printer can print like glass infused stuff. Like, so it's got to be. It can't be what you've made out the back. It's got to be what you cut from the manufacturer. But when you do that, you've got to like purge the chamber with nitrogen and that kind of stuff, because it oxidizes, and it's crazy. And this has got like nitrogen. You can feed nitrogen into this, but we don't do that at the moment because it's we've only got one of them. So
maybe in 10 years when they're
cheaper,
much cheaper, you can run that flat out. Like you've got your million printers out the back.
But even changing powder in this, you can imagine that if, say, this is nylon 12, if we want to go to nylon 11, for instance, because it's more flexible.
It's a friggin' exercise, right?
This has to be drained and cleaned. This has to be drained and cleaned.
Because that is all not going to mix with the other stuff.
Correct, yeah. So it will...
So how do you only print nylon 12 at the moment?
Yeah. So...
For that reason, right?
For that reason. So...
And is nylon 12 the most diverse material you've kind of picked for that reason? Because it
for automotive
kind of does everything?
Yeah, for automotive land, 100% nylon 12 is the way to go. Nylon 11 is generally the other thing that's printed with. Again, there is glass fiber stuff. We haven't really wanted to use that yet. We haven't really found a use case for it. Yeah. So with what we do, obviously, you know, there's a use for it in the world, but we don't really, for what we do, not required. But
then obviously, logistically, like you were saying before, there's just hours and hours in actually effectively sanitizing these machines.
Correct.
To be able to actually go to a different material.
Yeah. And you've got to store this, pack it somewhere. And then you've got to like put it in. So if you say to me, like on a normal printer, you can go, oh, here's a pink roll or a green roll or something like that. You can just purge it out and it's quickly done. Yeah. This is like maybe a 4-hour operation just to drain it and start again. So obviously if you have more than one of these machines, you can then diversify, but trying to do it like this is with one machine is hard.
Yeah.
And
sick.
Yeah, cool. So let's finish
find
digging
the
them
fossils.
out. Yeah.
Tell me what to do. I don't want to do the wrong thing.
There you go.
Cool.
Here's a brush, and there's a part, and you just start scrubbing.
Work experience, Willie. Jeez, it's warm.
Yeah. If you were cooked at 180 degrees, you'd probably be warm too.
Yeah, the cake's ready.
Yeah. So he's already learning. He's already gone to the hand method.
Is this the next evolution?
Yeah, so you basically, I find, I mean, look, everyone's going to have a different way, but I
Yeah.
just break it off by hand first.
Yeah, because you could spend hours on the brush, right?
It's all loose, and then what you want to get to, so like all these, you just, pop your finger through the holes,
Yeah.
pop them all out, and then you use just your toothbrush or something like that to...
Do you kind of just do the hand method on everything, then come back with the brush?
Yeah, it's the quickest way I've found.
What is this piece?
That is a modified air intake for one of those like canister pod filter adapters. It's like the intake snorkel.
Yeah, okay.
So it's like to vent that off under the headlight for an old Falcon that we've been asked to do. And
yep.
And then this is
like one of those like old growler intake type sort of things.
that kind of thing. And then this is the other side of it. This is a MAF to the pod filter adapter.
Yeah, wow. It's crazy because you look at it and go, oh yeah, that's clean, but why is it all lumpy? And then you get the brush out,
Yeah.
and it's like, oh, I've just found a fossil.
So the print has this stuff called armor on it. So there's like when it lasers, there's a hardened section in the middle.
Yeah.
And then it turns the laser power down and prints armor. And while I'm not exactly sure what the armor's for, it's essentially to hold the part together
Yeah, okay.
while it's printing. So I'm sure the person who engineered this printer will know exactly what that's for.
He'll tell us.
Yeah, he'll tell us.
In the comments.
Yes. Form Labs are listening.
The day this episode comes out.
Yeah.
What kind of temperatures can this withstand?
Around 150-ish, I believe. So plastic has this like glass transition temperature. So things like PLA, which is like the real simple FDM plastics, will start to transition back, or start to warp at about 60 degrees, and then ABS is about 90, 100, somewhere around there. And this can go. Some of this stuff, depending on what you're printing with, can go up to 200 degrees before it starts to deviate. This stuff has less heat resistance because it's got that flex to it. So by adding more rigidity, then it gains more heat resistance generally. So the noise you're hearing is a vacuum fan. So this station, the reason why it's kind of covered up is it's a negative pressure vessel. So it's you can see the dust that is coming off the part getting pulled into a HEPA filter, and then so before it pumps the air out the system, then it's all clean. So it's not sending the particles around the room.
I can't believe how flexible that is.
Yeah.
Is that because of the temperature it's at still?
So it's a little warm, so yeah, it will, but as it cools down, it will stiffen up a bit.
Yeah, okay.
So the idea
So it is partly because it's currently
still a bit warm.
at
So we
70
don't want
degrees or whatever.
Yeah, we don't want to unpack the cake when it's too hot,
Yeah.
because the part will just warp, and so the cake is holding it together in position until it cools down. But if you cool it down unevenly, it's just going to warp and contort.
So it's almost like welding, like cast material.
Yeah. But this is probably the closest thing you can get in. Like.
So what airflow meter is that for? A Ford one.
So it's got the.
So it's like a AU or EL or something.
Yeah,
like 5 litre V8.
Yeah, that one. It's surprising that you just know that stud pattern equals that. Yeah. So
well, the 4 litre and all the 6 cylinders didn't have an airflow meter.
Oh, I see.
And then Barra doesn't have an airflow meter, and neither does
right
5.4.
You just know
I was like,
things.
it looks like a 90s F. Well, Fox Mustang had that as well. Explorer, all sorts of stuff.
It's like everything except like I know Volkswagens.
You do have a Volkswagen problem.
I do. I have.
You know what though? You have a very impressive, weird obsession with Volkswagens in that you just seem to be able to Rain Man stuff together and it works.
Yeah, I mean, look, it's just a lot of Googling, really. Like, is this going to work? Put it together. If no one's done it before, then just give it a go and see, and then just solve a problem at a time, right?
Yeah. And this is a pretty aggressive brush. Like it's not actually impacting the print or anything. There's no issues. Like that's pretty serious.
Yeah. It's it's a grouse material. Like it's really good, but Yeah, there's obviously, you don't have to go super hardcore on it, like we are going to blast a lot of it off anyway.
Yeah, well, that's the thing, like, I don't know.
Yeah,
I don't know how much you're trying to recover.
Yeah. So if you actually got your fingernail and drag it through it, you'll actually like be able to scratch the armor
Then
off.
I'll blow through the glove.
Don't want to do that.
Not my beautiful nails.
I won't be able to afford another glove. You'll send me broke.
We're going to lose the shop.
It's a slimline budget, mate. What are you talking about?
The glove intake, you get one a day.
Yeah.
I've actually got someone else is getting these gloves next.
That's right.
These are the show gloves.
So I'm turning the sifting on so it can now start. See how it's starting to suck it all down?
You're not allowed to sit on it while it's sifting.
Yeah. It's very therapeutic to like run your hand through, right?
Yeah. Like, I'd imagine this would be a pretty popular job in the winter.
Yeah. Except for having to like wearing a dust mask all the time kind of sucks, but you know it's better that than I don't know dying.
Yeah. Carcinogen plus.
Yeah.
So like once you get to this point and it has the auto sifting,
Yeah.
which is just turned off.
Yeah, that's alright.
Do you just like kind of heap it on there and then give it to Craig David? You just walk away from it?
So you just squish it down so it can like you actually can break down.
Oh, so the sifting, this isn't the sifting,
Yeah,
like there's more stuff under it.
This is a break. This is
kind of like version 1.
Yeah, and then it goes into a smaller sifting mesh, which I may have. So this is a 150 micron sieving sleeve.
Oh wow.
So that's the size of the powder that's going to go through. That's going to go through, and then the rest is just captured.
So 150 micron is what it goes back to put it back in the SLS.
Yeah. So there is a tighter one I think for you're going to print in polypropylene.
Yeah.
But yeah, again I think they're actually discontinuing polyprop because it doesn't really work all that well.
Yeah. Okay.
It's more of there's definitely materials that like so thermoplastics. There's definitely some that work as thermoplastics and some of them work as don't work as thermoplastics.
Yeah.
So they're injection mold only.
Yeah. Okay.
I guess the limitation between this and injection molding is that with injection molding you can kind of make a concoction of plastics and additives and things like that.
Yeah.
Where I'm kind of limited to I buy this powder in a box and I put it in the printer.
And hopefully it works.
And that's all I can do. So. Hello.
This is never like this is a addition to injection molding, right? Like do you think this will ever replace injection molding?
No, I think it doesn't. Well, look, not probably in our lifetime.
Yeah.
I think when there's like some cool replication. I mean, the difference between 3D printing technology from even when I started doing this to now is leaps and bounds.
Well, I remember like the first printers. I remember the very first printers you had.
Yeah.
You would buy one that was just good enough to print the parts to actually make it reasonable.
Correct. Yeah.
And you would like repair it with its own componentry.
So my first printer, I think I got in like 2013, 2014.
Is it that orange Prusa thing?
No, that was before that. So it was called a Velleman K8200.
Wow.
There's some real nerds out there that are like, oh my god, I remember that.
I've got 7 of them still.
It had the worst like kinematics model. It had all these problems with it, and it took me 3 months to get one printout of it.
I remember you and Marty like tuning printers like it was a friggin' hobby.
Yeah.
Like,
and now
this was like part of our every week meetup ritual was like tuning the printer, either your one or Marty's one. You'd bring it along and like change all the axis readings and like change screw pitches and all sorts of stuff to try and get it to work at a more linear rate and
like linear rails on the thing instead of like just the rods with bearings on them. Like complete change. And now it's like you pull a printer out of a box like a standard FDM printer, like an Epson printer or something like that, and you plug it in and you run a calibration. It's like done, print on me now, and that's it. Like it's.
But I guess it's like anything where. Even the printer manufacturers at the start were taking a gamble. Yeah. They could have gone and like dump $20 million into making something that may or may not work, or may not actually get people involved in it. Yeah. Like, because realistically, this is 10 years ago. Yeah. Or more. It was a hobby. It was never envisioned at the level you were buying at.
Or the level I bought it.
It was never envisioned in as being like you were going to make parts and sell them. It was like, let's print a cactus that's going to sit on your desk, or a pen holder, or...
It was like, this is a cool thing, I get to make stuff, let's do that. Like I'd make dashboard bits and things like that, but you'd do it out of like cardboard and bulk.
Yeah.
You know, like body filler, and you'd make, where now it's like, oh, I'll just draw it instead.
And print
like,
it, yeah.
So...
Like car audio fascias and all that sort of stuff that 20 years ago I was making out of fiberglass and like that sort of stuff.
Yeah, now it's not even...
You go, oh cool, I'll 3D scan it, and then in 2.5 hours...
It's printed,
You've printed a dash fascia.
Yep.
Or more than 2.5 hours, but you know what I mean.
So we actually had a conversation yesterday, one of the things that you wanted done for the Mark II, I hadn't even done yet. Because I'm just short on time. So this morning I drew it up, and it's on a printer now, and so by the time you leave today, you'll take it with you.
It's literally on the print right now.
Yeah. So anyway, let's take these to the next step. We've been piss farting about this for too long now. Got work to do, mate.
Sorry, Dad.
Come on, let's go.
How much cleanage is that good now? Like I just shake them out and send it?
Yeah, that's it.
Okay.
So we bring it to the next spot.
Come on, Gian.
Let me just get out of my little hidey hole.
So this is a...
Hang on, we got no camera. He's too busy unfolding himself.
Yeah, unfolding himself from the corner.
Oh, that's right. I thought that the SLS was in here for some reason.
No. So this is the sandblasting or media blasting section of the SLS. So this is a two style, so you can either manually blast something with the gloves. The good thing about this one is you get to, so normally with a sandblast box, you've got to hold the gun with one, and you've got one hand to try and move the part. This one you can do both, and it's automatically...
It's actually just mounted.
Yeah, or you can flip it that way, and then the drum will just rotate like your washer, and it will just
cement mixer job.
Yeah, just clean the parts for you. So I reckon we try automated first. We can take these masks off.
Sick.
So just hoik
I'll put them in there, and then we can demask.
Yeah.
And in the drum setup, it's fine that these parts are all in there together. They're not going to bash into each other.
If you've got little 1mm walls and things like that, stuff you're worried about, don't put them in the drum, do them by hand.
Yeah.
But ideally, you can just put this in the drum, put it on for 20 minutes. So while that's doing a thing, we'll go look at the
do
next
a load
thing.
of washing, and we'll go and do the cool stuff.
So we do that, and we turn the fan on, and then we hit start.
That's hackers.
So this is our broom closet of 3D printers. We obviously, all of our farm is next door, but this is just the ones we use for
your own prototyping.
Yeah,
right?
prototyping stuff we want to make. There's one I had to bring over from next door, but it doesn't fit on any benches because it's too big. So I'll let you go do the honors and remove
the dash around. So satisfying. I'll put that back so no one steps on it.
Yeah.
Why is the printer all bendy and broken?
Because Ben owns it now.
Now, what is that about?
So this is support material. So like we were talking about with the SLS stuff, is that when FDM goes to print, if there's nothing for it to sit under, it just droops material onto the ground. So it builds this support structure. This is called tree support, so that it can print things in the air.
This looks very AI to me.
Very slicer program, very computer generated, yeah. So, but it's very satisfying to just...
Oh, you broke it.
Yeah, oh well, bin it. Yeah, so you get to sit there with a pair of pliers now.
Cool.
And break it all off.
Right, thanks.
And then, as I said, there's a keypad thing in there happening now, and we've got a sand disc, prime it, paint it.
When you say we,
I mean, you're the apprentice today, aren't you?
I'm not a painty guy. I don't painty.
I'll take on that role then. It's
nice. You know a guy?
Yeah, I know a guy. If only we had a paint booth next door.
Let's go and look at other stuff.
All right.
I feel like I'm crushing cicada shells. That's what it feels like. That's the consistency of it.
Do you like it though or not?
No, I mean I'm impartial to it. I don't live to crush cicada shells.
Yeah, fair enough.
That's not what motivates me in the morning.
I'm kind of glad.
This could have been an interesting conversation.
Yeah. Back away slowly.
Yeah, this is raising more questions than answers.
Yeah, a pair of pliers is definitely the go-to at this point.
No.
Unless you've got, I mean,
I've got tradie hands, bro.
Your fingers don't have feeling in them anymore, so.
Yeah, I'm a robot. Meat mob. Look at that. Full robot mode. I guess the other thing with this style of printing versus SLS is there is that potential for separation in the print if you don't layer it properly. Is that a thing?
So
like delamination of the layering?
Yeah, delamination can happen if the layers aren't bonding well together. You've got warp as well. So when the print's on the build plate, ABS, if you've got large areas of ABS plastic or any plastic in general, and then a really small area, it's going to want to contract around the large mass to the small mass. So you want to try, this is why injection molding, there's like fins rather than just large molts of because
it puts all extra structure in there.
Yeah, well you're getting a sinking mass on one side, you're getting all this sort of stuff. So printing kind of doesn't want to have, FDM printing doesn't want to have large bodies of plastic. Yeah. So we want to try to keep the walls thin. We're trying to keep.
And is that why all the support structure is also very
one wall? Yeah.
There's probably two reasons, right? Like that is also to encourage it not warping.
Yeah.
But also to just minimise wastage.
Yeah. Yeah. But I mean, like we were saying before, like all this stuff here, this is dead. This is dead. Like, yes, there are people who sit there and run it through a grinder and will make filament again. But overall,
the time is worth more than the material, though, right?
Because it's also been run through a system once already. It's
the plastic's been heat cycled.
Yeah, it's not as good as what it once was. It's harder to print with. It might warp more. It's got contamination now because whatever's on the bench now, it's not.
And the thing is too, you've also got to look at it from a business case and go, is this going to impact on the quality of our product? Yeah. And the answer is yes.
Yeah, 100%.
Miles is just making me unpick this one.
Yeah.
There is here's one I prepared earlier.
Yeah, this is one that we've already, because we weren't sure of timelines and stuff, so we have already printed this one, picked it clean, primed it and painted it. So we've gotten all of the layer lines out, well, most of the layer lines out of it anyway, all the bits you're going to see. The rest of the backside we don't really care about, but you know, what's visible on the car we've neatened up.
Just look on the back.
Oh yeah, taking all the bits out there. But we still have a use for this one. It's not going in the bin. You said someone wants one?
Going to Alan.
Yes.
Because young Gus has got the modified car bug, no way. And he's actually building now he's actually building a Cresta. So he's doing a JZ Cresta with some Haltech goodies, including a UC10. So it worked out pretty well that A, we could do 2 prints, B, it's not going to waste, and C, he's got something to put his UC10 in, so everybody's winning. And he can do the weeding because that's his problem now. Don't you want your witch's hat?
Oh. Yeah, that's satisfying. When it does that. Oh.
Get in, boys. That just saved 10 minutes. Product placement, 500. Not your first rodeo.
Hopefully it goes in.
I'm pretty happy with that attempt, considering I've used no tools.
Yeah. I mean, these are tools though, right? Like these are...
My hands.
Yeah.
They're finely tuned instruments.
Yeah, that's right. Been hit with how many hammers?
Oh, a few.
Yeah.
I tried to crush my right hand under a ladder the other day. That was fun.
Oh, good. That's not what you want to do, but...
No. The ladder slipped again the other day.
Oh, wow.
And I had my hand up here, and the rung was there, and then I was like, hand guillotine.
Oh.
5 out of 7 recommend.
A mechanic with one hand isn't a very good mechanic.
No,
actually no.
He's more of a mechantic.
So one of the things we do after we print the parts is we paint everything. So we have all these like board stuff, so we can actually just place all the sensors directly into these. We print little standoffs for our paint boards. Obviously this one's due to be retired, but we print little standoffs so that the boards can sit and the sensors sit in there. And then we've got a industrial food dehydrator to help in the winter months dry the paint. So
everything I see here is just maximised.
It's just
that, or you're going to diversify into beef jerky. I'm not sure yet.
I don't know if you want painted beef jerky, but we can try. It's all come from necessity. Like it's all like we need a bigger oven, and then you're scrolling through Facebook Marketplace and you happen to see a food dehydrator. You're like,
that'll work.
Let's use that. We could go buy a powder coating oven at $100,000 or whatever the things cost these days, or you could.
But you don't need that temperature though either.
No, like this paint, it's like 1K paint. It bakes off at maybe 30 degrees, 40 degrees. So we just need something to be able to when it's 9 degrees outside and the paint takes 3 days to dry. We
just want it to flash off in a more efficient time frame, right?
Yeah, that's it. So
are these like previous ones that have now been retired because of that?
Correct, yeah. So this is where we've had this paint booth for a really long time, and this is what we used to do before we did that. And then when we've even got overflow, one of our old customers made this for us and he decided to, but the D hole's missing.
Yeah, everyone needs a D hole.
But let's look at some printers.
This is pretty wild.
Yeah.
I remember when you had like 9 of these in your garage.
So yeah.
Is this the same printer you had at home now?
No.
So these are newer again?
Yeah, so we went from Perugers. We had a couple of Perugers, probably 6 or 8 of them, something like that worked at any one time. There was one always broken.
Yeah, I feel like you're always on rotation of one dying.
Yeah, and so now
But I guess it is fair to say you are literally running this 24/7, so you are going to have downtimes and
100%.
braking, and
some of these printers have 6,000 or 7,000 hours on them.
What is a reliable number on the printers in your experience? Like when you're running these bamboos, like how many hours do you run one of these before you consider it, I guess, a risk?
Well, risk is like once it starts failing, it's more.
Or is it literally case by case?
It's case by case. So if a printer just starts to have consistent failures all the time, then it's taken out to the farm and put to pasture. It's stripped down for parts to then fix another one. But I essentially you just keep printing on them until they are not.
Okay. So you don't go, at 8,000 hours they get retired.
We looked at doing it, but honestly, they're cheap enough to buy, and just keep expanding the farm. And as they die, we always have like a couple spare just to sort of stock them in.
I suppose the other thing is if one does cark it mid-print, you're not losing $500 worth of print. Like it's another 2 or 3 hours of like reset.
Yeah.
Or replace the machine and go again.
Correct.
And like you say, these machines have come so far. You don't have to like spend an hour leveling it and making it all happy. It's like calibrate print.
You can buy one from like direct from Bamboo. It'll turn up in a couple of days. You can plug it in and start printing stuff. And so, there's certain models we print now that we're actually pushing it back into injection molding because it's not feasible to make the many that we do. But we're still going to be printing a lot of stuff.
Yeah, so a couple of your most popular part numbers are now actually going back
into injection.
So I guess that's the inverse of my question is you've now gone from printing to injection molding.
Yeah, because it's like you wouldn't 3D print
a car.
Straws.
You wouldn't download a car.
You wouldn't download a car. You do now. I've probably got about 10 models of cars at the moment. So, but you're not going to print something. You're going to you buy a pack of 500 straws, and you go and use 500 straws. You're going to print a straw.
You're the sort of guy that would print a straw, though. I reckon you'd
have to be fancy. It'd have to be really fancy. Like have one of those lids or something. Yeah, or one of those glasses ones or something like that. But yeah, so there we've got some cool ones down the end there. So there's 40 machines in total over here, and there's spatterings of ones around the rest of the place. But the 8 down the end there, they do something cool. They've got auto ejection.
Oh, stop it.
So Ejecto-cedo, exactly.
And these have also got different filament rolls on them, or is it the same one that?
So
is this like auto loader that?
Yeah. So this is their AMS system. So we have this in backup mode. So the way this works is when we've got all these filament spools here that are like say half runs from the other printers, and if the printer's not going to finish a run on that spool, instead of losing the time, we put the half spool into here, and so when this one runs out, it jumps to the next spool and the next spool. And
mid-print.
Yeah.
That's so good.
And then these printers, the reason why they're mainly on these ones is because they've got auto ejection. So once the parts is finished, we just push it out.
Yeah.
And it will start again. And so it keeps doing that until it essentially runs out of filament, and you just end up with tubs and tubs and tubs of parts like that down there.
Why have some of the printers got lifted spaced off lids?
Because that was the thing that the guys put in, because let's call it design flaw. So that to print the spaces, we need that printer that we printed your cluster on.
Yeah.
And
I was looking at it, I'm like, it's one print.
So the PTFE tube that runs from the back of the printer into the nozzle without the spacer rubs on the glass.
I saw that on some of them actually. There's like a witness mark.
Yeah. So eventually it rubs through, and if you get the PTFE like bits of stuff
In the filament, in the nozzle.
it clogs it because the printer can't extrude the PTFE because it's got to be extruded at like 400 degrees.
Yeah.
So it clogs the nozzle, and then it starts destroying nozzles. So
Cool.
they're like $60 a piece to replace them. So printer spacer fixed.
And it's only like 15 mil. Like
Yeah.
it's not a lot.
Yeah, it's, as I said, it's a full.
It's just
just a design flaw on their part where they've just gone and they've tried to squish the printer as much as possible.
Yeah.
But
get the biggest print volume in the
Yeah.
smallest footprint.
But funnily enough, they give you in the printer, they give you spare PTFE tubes.
They know their way through it.
So they know. Yeah.
We are pretty much at the end of our Flux tour. We do have a mix of parts that Mars has made for us. We're still prototyping this piece, which will actually replace the radio panel in a MX-83 or a GX-81 or a JZX-81. As far as we know, it's right-hand drive only. This particular prototype actually has a switch provision, and these are, I believe, a Toyota genuine switch or an aftermarket version of.
They're aftermarket version of like the Prado style switch. So it's a 22 by 22 mil Toyota switch.
Yeah.
They're available from every switch company, AliExpress, wherever you want to get them from. They're all over the joint.
Sick.
And yeah, it was just a panel like.
Literally a concept, right? Go, oh, cool, we
Yeah.
can put switches in it. We can make it bare. We are actually looking at also making a replica or a reiteration of the satellite panel. Anyone who's into JZX81s or GX81s will know what that is. So we are looking at making that at the moment. So yeah, hopefully in collaboration, we'll be bringing some pretty cool products to market for the X8 platform with Flux. So yeah, watch this space. We are going to be bringing some stuff out. But speaking of bringing stuff out, tell me about what you guys actually do as far as making products.
Yeah, so we've just got a couple of samples here, I guess. So these are just a basic sensor bracket. This one is for a PX Ford Ranger, if you're keeping track. So just simple reverse sensor bracket with a, this is a 32 mil hole with a
Nut
arrangement. One day I'll get on because my fingers, I sit too long behind a computer desk now.
Too many of these ones.
Yeah, that's right. So yeah, just a simple nut. This tightens up. We put these little trays, canopies,
Does that
that kind of
also
stuff.
suit front sensor, or is that a different thing?
Yeah, so we just say it's park sensor now. We don't say,
front or rear.
We just say park sensor because
I just didn't know if they had a different sensor physically, front or rear.
the only car that has a front sensor different front or rear is a facelifted first gen Amarok. There's
course, you would know that.
There's my Volkswagen knowledge for you again. Yeah, every other car, front to rear, that's the only car that
Makes
decided.
sense, right? Why would you? It does the same job. Why does it matter where it is on the car?
Yeah, exactly. So,
Sick.
and then just some camera brackets and that stuff. So these are just for when you take your camera out of the tailgate, you've got nowhere to put it. So these just hang under your tray. So imagine
That's a tray.
that's a tray. It's a weird looking orange tray, but it's a tray.
And you can actually change the angle of that to suit driver position or preference.
Well,
or
so every tray is going to be, some trays are here,
Different
some
height,
like
yeah.
that stuff. And obviously, a lot of times the guidance lines are built into the camera feed, so you want to be able to adjust that. So we give it a hinge joint into it.
Nice.
So yeah,
That's cool.
and then we've got our parts that we
These are things we fed into the robot sandblaster,
Yeah, and
which in
they're-
itself is hectic.
yeah, and it's nice and smooth. Saves us a whole bunch of time. So
And these, you were just obviously doing the squish test. These are a lot more rigid now than when they came out of the cake, which is pretty cool.
yeah, so the more they like the hotter, and this is that whole temperature thing I was talking about. So the hotter they get, the more like obviously that flexes now, but if it's too hot, it'll just flex and stay there.
Yeah.
So obviously there's a a working temperature range, but for an air intake, if your air intake is higher than this stuff's working temperature range,
You've got bigger issues.
Yeah,
There's
the
probably fire involved.
there's the atmosphere's on fire kind of thing. So
or the car.
that too. So
And you also do make stuff for other people, right?
yeah, so we do like a little bit of discrete manufacture. This is just an Anderson plug holder for
A tray manufacturer.
yeah, and so just a simple thing. They gave us a model. We sort of went, well, if we're going to print it, we'll fine tune
Tweak
the
it.
model to make it beneficial to print, and also. So normally what they were doing is actually putting one set of bolts through for Anderson plug, where this design you just
One
put-
nut and bolt the whole way through.
Correct, yeah.
That's good. And it just sandwiches it.
Yep.
That's cool.
And then it saves a lot of obviously saves a lot of hardware, but a lot of like
just man hours assembling it all. Yeah.
So there's just a lot of like improvements through engineering. So you can remove a lot of material. You can that'll add material in wherever you need to, and then just like because now you can save yourself. It might only be a couple of cents per fastener, but
when you're assembling 500 of them, and even the man hours too.
Yeah, that's right.
Like you can put 100 of these kits together in a day instead of 20 or 50 or whatever.
Yeah, that's right. You're not like trying to pop rivet each one in or something like that. That's what they used to do.
Another thing that we were talking about, I don't know if we spoke about it on camera, but you also, if people come to you with a design, you can actually help refine or re-engineer it for printing or for a certain application as well.
So if someone comes to us and goes, look, I'm halfway through a design, but I can't get this done, we can assist where we can to try and make it, or like better, and we can either print the part for you, or we can give you the file back and say, here you go, try it out.
And you actually have engineers. I mean, I know you do a lot of design yourself, but you have also engineers full-time as well.
So it was just me. So trying to run a business and be the designer became a very big linchpin for the company. So,
we've had many of these conversations.
Yeah, so we've since hired one industrial designer and one mechanical engineer.
That's cool.
And they're awesome. They're not, one's a car person, one's not quite a car person, but she's quickly becoming a car person, being around here.
Force of habit at this joint.
Yeah, that's right. Yeah.
That's awesome. And speaking of cars, you do have a couple of your own projects here, and one that's a blossoming project.
Correct.
Let's have a bit of a walk around before we go home and see what that's about.
Yeah, cool.
So this is probably the, I guess, original Flux project car. This has had tons of different ideas, concepts developed. I reckon I've seen about 10 different intakes on this thing over the years of you changing different layouts and all sorts of stuff. And it's cool to see you've retained things like the factory airflow meter. And for anyone who's got half an idea about this, clearly this is not the standard engine. So tell us a bit more about it.
So I bought this car. It was the cheapest BRZ I could find.
You should use that as a YouTube
I should.
introduction or title.
It wasn't sight unseen though, so
ruined.
Ruined. So I bought it in 2019 for the sole intention of putting a LS swap in it. They had been done in Australia before. They've been done in the US heaps because they're like junkyard motors over there. Bought a it's a 2012 model BRZ with a 2013 6-litre LS. This is an L77 variant.
This is out of a VF Commodore?
VE2.
VE2.
Yeah. So it's still got the DOD stuff in there. It's just because it's now manualised. When they were in the manual, it all got turned off.
Yeah.
So it's got a TR6060 hooked up to it is basically a stock rear end. It's but it's the Lexus diff, which is a 3.5, I think.
Yeah. So still the G series diff, but with a 3.5 ratio set up.
And just a custom prop shaft in there between there.
Nice.
E38 ECU, so stock ECU for the motor, and a translator card which makes the ABS,
traction control,
all the
electric
factory
steering,
stuff work.
aircon,
so
the whole box and dice. So this operates 100% as a factory car.
Correct. Yeah. So aircon, ABS, traction, everything is still there and functional.
That's hectic.
So, yeah,
this thing's cool.
Yeah,
makes the right noises.
Yeah,
and drives. The biggest thing I've always said with the 86 BRZ platform is it's such a nice car, it just needs more power. And this is, I reckon, probably the actual best way to do it.
Yeah.
I feel like turbocharging or supercharging the factory engine, not so much. They're a bit of an Achilles heel when you try and do forced induction things.
Yeah.
Having just sheer cubic capacity is always going to make it better.
The fact that, I mean, everyone who says, like, I pop the bonnet of Cars and Coffee or something like that, they're always like, it just fits so well. Widthways it does, this way, like lengthways, there's obviously clearancing issues and stuff like that, but it actually all fits without.
The car's not cut.
No. It's all original.
Just packaging, it's just a lot of hours in. I remember we talked about mounting, and I think you bought a mount kit or something from the US, and then it was so far out you ended up making it all again.
It was 30 mil further back, so I couldn't run aircon.
Which I don't know how.
Core. Yeah, like I don't know how they expected it to work, but I just remade the mount, brought it forward again. Probably my first thing. Before I had a 3D scanner, I did that, so it was all a lot of like hanging the motor from a crane.
Heaps
and
of CAD. Cardboard CAD.
Cardboard CAD. So then drew it up. That was my first laser cutting project. Sent it off to the laser cutters to get them to do it.
So this is like you honing your craft into what is now this. Like the design aspect and the concepts and planning and
like setting it into actually into it, like making a part that is functional rather than, because a lot of people are like, oh, I made a thing for my car. Like actually making like functional, usable parts that basically people aren't going to see. Like, like there's around the gear shift adapter, there's a whole bunch of printed stuff around with like heat shielding to try and obviously fill up the hole. Stuff like that, just trying to, but no one's ever going to see that.
But it's the things that make this like a factory car.
Yeah.
Because you don't have that heat management issue of heat coming through the transmission tunnel.
Correct, yeah.
The gear knob's not hot because it's just getting radiant heat forced on it all the time.
That's right.
But these are the kind of things that people don't necessarily think about, or product designers don't think about, whereas someone like yourself who's been on the other side of it, building cars and designing cars.
I feel like if you have to work on the car and engineer the car, I think that's
the best combination.
Yeah, because like the engineers, like let's put the starter motor in the valley, like all that sort of silly things on BMWs.
Starter motor and bell housing.
Yeah, like starter motors inside bell housings and that kind of stuff. Where I feel like when you have to build it,
but then also maintain it.
Yeah, maintain it. You have to sit there, like oil filters aren't so far up the guts of the motor, you have to have a third joint in your arm about there.
Yeah, you got 3 people to change an oil filter.
Yeah, so
so this thing's cool and it does on-road things, but what's the story with the Amarok?
So I feel like I just motor swap white cars because this is it's a 2-door Amarok that was originally a 4-cylinder petrol. Yep. And that normally runs like it's a modified Mark IV Golf engine.
Yeah,
roughly.
right. Mark IV.
Mark IV.
Wow.
Yeah.
Vintage.
I think it's a Mark IV. Probably someone will say I'm wrong.
It's a Mark V one.
Might be a Mark V.
Anyway,
so you can't buy a V6 in a 2-door.
Yep.
So the only thing left of this car original is the chassis rails and the cab itself. Yep. Everything else from headlight to tail light's been changed. We bought a stat write-off V6 and basically just scooped it all up.
So for anyone who's not Australian, a stat write-off is like basically insurance companies deemed it a total loss.
Yeah.
For whatever reason, you can't register, and then that VIN then becomes black labelled.
Yeah.
So for that reason, you couldn't just plonk the 2-door cab on a late model V6 frame. You've got to go the other way and use the cab and the frame from a single cab one, and then put all the good stuff in it.
Yeah, so the single cab has like an untarnished VIN, and then the stat write-off, basically everything, as I said, like
the
rear
donor
diff,
car,
suspension, everything that could be unbolted from one, wiring harness, headlight to tail light, dashboard,
doors, guards, front panels,
everything.
Because the front end's facelifted too compared to the original car, right?
Yeah. So I mean, there's got a bull bar on it, but like, so the other thing with it is, so then we had this train canopy made for it. So this is actually from Mitz Alloy. It's originally designed for a GU Patrol, but it fits perfectly with the proportions I wanted. So it's slightly shorter. It's not a big...
Yeah, you're not trying to lug pallets around town.
No.
We kind of already touched on it before, but in the actual canopy, this is set up for 3D scanning on site. Yeah. You've even actually got a printer installed in there.
Correct.
Which means you can actually do rapid prototyping on site.
Yep.
You do a lot of consultation and stuff for third-party companies, like you say you do some of that white label type manufacturing. Yep. So rather than have a drawn-out process where sometimes you need the vehicle to come here, you can actually go to them and do the work. So even on-site 3D scanning, that's becoming more and more popular for people designing things.
And it's because obviously, like your car, I can be like, you just put on a trailer and you're like, well, that's really not helpful, right? So for us to go out there and do it. Probably the last thing on it is no auto Amarok ever came out. Well, auto 2H Amarok, which
What's
is
the 2H?
The first gen.
Okay.
So the new one, which is the Amaranga, which is called a
Ford one.
A Ford one, that one. These ones never came with low range. Yeah. So this has been retrofitted with low range from a manual and made to work on an auto. So the
manual transfer case actually bolts to the automatic transmission?
Correct, yeah.
Oh, sorry, transfer case? Yeah.
So the manual transfer case bolts in. Electrically, it's a pig because the transfer case module doesn't want to see the ABS module, and then the gearbox doesn't have any mapping to work in low range. So basically, you got to remap the gearbox. You got to make the ABS module happy. You got to all this like.
And this is all stuff you've just worked out, right?
Between
for the most part.
Yeah,
But what I mean is, No one has done this conversion before.
Not that we're aware of.
Wow.
Yeah. So, so you get little bits of information. Obviously, I'm not just like sitting in a hobbit shack by myself. There are people that, you can go and ask certain questions to, but no one's got the full answer. And so one guy might know how to fix the ABS and the other one knows how to fix something else.
The transmission coding.
So we kind of did a bit of transmission stuff, and there's a guy in Queensland who races these and has got a drag racing tune. So this gearbox.
Sorry, what?
Yeah, he drag races a diesel two-wheel drive. Two-wheel drive V6 Amarok. He's got a.
Is that such a thing?
He has made it one.
Okay, right.
Yeah. But yeah, there's obviously complexities with that. This gets axle wrap now because you got 700 odd Newton meters trying to go through back wheels, and the leaf spring wants to turn into a taco. So we've got to work out how to fix these problems. But low range wise, like none of them ever came with it. So it's a bit of a Frankenstein unicorn, everything in one sort of thing. So but it's
really cool.
It's a cool thing. It's I've got nothing else in my life to do, so I may as well fly cars.
No, it's really cool. And then what's the deal with the paperweight on the hoist?
The paperweight on the hoist. So it is a up. It is not the up. It is a car I found on Marketplace for
no way
for $3,000.
I'm shocked and surprised by the fact you found a car for sale on Marketplace.
Yes, and I think for anyone who knows the story about myself and Mighty Car Mods and Ups, this car has a blown ECU. So I thought the story wrote itself. Yeah. So basically, we thought about just putting an ECU in it and do a quick flip on the car because it was Queensland regoed, so we've got to get it blue slipped and stuff. Hence why there's no plate.
Yeah.
So we've got to get it regoed, and then we would, as I say, just throw a new ECU in it, fix the problem that happened. Long story short, the coolant sensor purged coolant and somehow it pushed coolant through the harness and it got into the ECU as per the VW.
Sounds like a Volkswagen thing.
Yes, 100%. It's like the ECU. Sorry, the wiring harness became a coolant passage, and then it ended up in the ECU. That's what VW has diagnosed it as a dead ECU. So
cool.
I bought this, and now I've bought another Volkswagen, which is a 2015 Caddy with a 1.4 turbo.
And it's worth mentioning the 1 litre in this and the Caddy is actually the same engine family.
Yeah, so it's like
3-cylinder, 4-cylinder version, right?
Yeah, so there's everything from 1 litre 3-cylinder up to 1.4 litre 4-cylinder, NA and turbos and stuff. It's all the same family. So it should, in reason, just
bolt in.
Just bolt in, like certain brake kits.
Looking at that engine mount, I reckon that they've made a big offset in that.
Correct.
So that the 4-cylinder just absorbs that space. And hopefully there's a tiny little tab on the timing cover that just goes clunk and you're done.
This is the hope. Obviously, we don't know just yet. Obviously, we did
Is this another one that no one's done before? Or is that a fairly common conversion in Europe?
I haven't seen anyone do it. I've seen people do 1.8 litres, but there's a lot of fab work in the 1.8 from a Mark V Polo.
But that's a different engine, right?
Yeah, completely different setup. Different motor. Obviously there's the 1 litre, so the GTI swap, which is in a lot of it's the same engine as what's in a Polo.
Polo GTI?
Yeah,
or
no,
non-GTI?
just Polo.
Yeah,
straight Polo. And the Polo GTI I think has a 1.2 or 1.4 or something like that. Anyway, the motor that's going in this will be out of a Golf. So it'll just be a basic 1.4 litre Golf engine.
Yeah. What's that TSI?
TSI 1.4 turbo, sort of thing. So hopefully we're looking at the motors side by side and it all looks like it'll line up. Will it clearance? Well, we've got grinders for that. So we'll see how it goes. But and we'll try to do a 5-stud conversion on it instead of 4x100s. That kind of stuff.
Go 5x100 or something.
Probably end up in Volkswagen land, so it'll probly end up as 5x112. Whatever that is. It's gross, but 14-inch 4x100s are also not, not living the dream either.
It's a cool thing.
Yeah.
That's awesome, man. Thanks so much for having us down. Hey,
thanks for coming.
really appreciate it.
Yeah, yep.
Thanks for doing all the cool stuff.
I hope all the stuff fits.
Oh, I know it'll fit.
Yeah, good.
Everything else is fit, so no pressure.
Yeah, no pressure at all. just tell me if it doesn't, and I'll make amends.
It'll be sweet.
Yeah, sick.
Nah, really appreciate your time, mate. Thanks for having us down here. It's really cool to see what Flux was and what it's become.
Yeah.
Like I said, I remember when you were in a 2-car garage with your little print farm going, and then now there's like 60 printers on site here just doing all different things. So really appreciate your time. And if anyone does need any 3D printing stuff, by all means, reach out to Miles because he does take on projects. But it is worth mentioning, if you do need design work, it's not free. So keep that in mind. Thanks for watching, guys. We'll see you next time. So satisfying.
Now, does it fit?
It'll be fine. Like a glove.
And it's going to go.
So that's like the sandwich piece that holds it into the dash fascia.
That's it. And then this is all sculpted to fit the dash.
This guy, people.
I try.
Thanks, mate.
Take your timber.
Yeah. Time to go and put it back together.
Yeah.
We're supposed to do the other half of the episode is putting this in the car.
Oh,